Good day, class. We are now on the fourth week. We will start discussing Module 4. I hope you will enjoy our lesson. Before we start, let us pray. Lord God, thank you so much for giving us another day to study and prepare for a good life in the future. Before going to our topic, let me ask you to share your thought on the things you do under the heat of the sun. For me, you can see on the images on the screen that I usually start my day with doing things that will make all things right. And of course, I enjoy eating under the heat of the sun. Now, how about yours? Later, you can give your answer or your idea on the chat box that we have, and you can share it in our Padlet. Okay. So, in our module, in What I Know, you can go to our classwork week 4 in your Google Classroom and answer your Google form on What I Know. It is a 10-item test. Now, what's in? Okay, last week we started discussing the difference between potential and kinetic energy. So let us recall our topic last week. So you need to sort the following according to the forms of energy. We have two forms of energy rather. We have potential energy and kinetic energy. So we say that potential energy and kinetic energy, when you combine these two, we have the mechanical energy. So let us sort these examples into what form of energy. Okay, the running boy, a spring, okay, waterfalls, a moving car, a stretch slingshot, rubber band, rolling ball, and dancing people. Okay, so let's go to your answer. So a running boy, definitely it is a kinetic energy. Example of a kinetic energy because it is in motion. While this spring, we consider this as, or it possesses potential energy. And what kind of potential energy? It is elastic potential energy or elastic energy. Why elastic? Because you can compress. Okay, you can compress this material, and then after releasing, it will go back to its original shape. Now, how about the waterfalls? Waterfalls is potential energy, and then what type of energy or what form of potential energy? It is gravitational potential energy because of the height, the distance, and the water is being pulled by the gravity. And then this car, we assume that this is a moving car, so it is kinetic energy. Now, how about the slingshot? Okay, the slingshot, once you stretch the rubber portion of the slingshot, okay, it will be stretched, so it has elastic potential energy. Same with a rubber band, you can stretch the rubber band. Now, if you keep on stretching the rubber band and then you release one of your hand, so once you release, it will go back to its original shape, and it is said to be elastic. But as I have said before, not all elastic material can go back to its original shape because there is a point wherein this elastic material could break off once it reaches its elastic limit. Okay, how about this rolling ball? So obviously it is kinetic energy because it is moving, the same way this dancing people. Now let's go to the next. So let us try to fill up the blanks in order to check whether you still remember what we have discussed last week. Potential energy is due to its blank and blank. So the answer is potential energy is due to its position and configuration. Okay. Number 2. Blank is the SI unit of energy, so the answer is joule, correct, or capital J. Potential energy due to its height is gravitational potential energy. And number 4, stretched rubber band is an example of elastic potential energy. And last, 5, blank is energy of moving objects. It is kinetic energy. Okay, I hope you got it right. Now let's go to the mathematical portion. Okay, let's compute or let's solve. Now on my example, you can see on the figure that there is a ball on top of the cabinet. Since it is on top of the cabinet, it has a potential energy stored in it. And then there is a height because it is on the top. Now, compute for the potential energy of the ball with a mass of 1 kilogram and seated on top of the cabinet with a height of 0.6 meters. Now, the formula in getting the potential energy is getting the product of mass, the acceleration due to gravity, and the height. When we talk about mass, we said that mass is the amount of matter inside an object, and the unit that we are using for this is the kilogram. Now what if the unit given is in grams? So we have to convert it first into kilogram. So in converting units, remember the relationship between the two quantity. So kilogram and gram, what is the relationship between the two? We said that for every 1 kilogram, it is equivalent to 1,000 grams. But if the given is already in kilogram, so that's it. Now how about G? Small g stands for the acceleration due to gravity, and we say that it has a constant value which is 9.8. Okay, others 9.8 meter per second. Now others, instead of using 9.8, they round off this number and then they are using 10. So it could be easy for them to multiply. So 9.8 or 10, and height. Since we are talking about gravitational potential energy, so we need to check the height, and the unit of the height must be in meter. Okay, now what if the unit is in centimeter? Again, you have to convert meter to centimeter or centimeter to meter. And the relationship between meter and centimeter, we say that for every 1 meter, it's equivalent to 100 centimeter. Okay, let us solve. So the given mass is 1 kilogram. Okay, acceleration due to gravity is 9.8 or 10. And the height is 0.6 meter. So all we need to do is to multiply the three given. So substituting the formula, mass is 1 kilogram, g is 10, and then height is 0.6. So 1 times 10 times 0.6, it is equal to 6 joule. Okay, since it is an energy, meaning to say the unit is in joule or capital J. Okay, I hope you got it right. And then next, we solve again another problem, but this time we are solving kinetic energy. So the the formula for kinetic energy is 1/2 mv square. Okay, others, instead of using 1/2, they convert this 1/2 into decimal. So equivalent of 1/2 to decimal is 0.5. Or the other way around, they multiply first mass and the square of velocity after getting the product divided by 2 since it is 1/2. Okay, so let us try solving the problem. Compute for the kinetic energy of a car with a mass of 800 kilograms and a speed of 60 meters per second. Okay, substituting the formula, the given mass is 800 kilograms and then 60 speed. So we need to get to square this. So 60 times 60 is 3,600 times 800, and then after getting the product divided by 2. Okay, so I hope you got it right. So it is 1,440,000. Since it is kinetic energy, again the unit should be joule or capital J. Okay, so let's go now to our topic, which is heat and temperature. So others mistaken these two terms as they are the same. But heat and temperature are totally different, but they are related with each other. So let's see. So to start with, we need to check the sources of heat. Okay, so the main source of heat is the sun. We also have the burning wood. Okay, the fire in the burning wood. Okay, the open stove, a candle, lighted candle, and the geothermal plant, and then we have the lamp. These are some of the sources of heat. So let's go to the difference between heat and temperature. So if we check the concept of temperature, we say that temperature is the degree of hotness or coldness of an object. Gaano kainit o gaano kalamig ang isang object, ang isang bagay. Okay. So with this image, when you touch the cup of hot coffee, if it is very hot, okay, you will be burned. While if you are going to touch this glass filled with water and ice cubes, definitely this is cold. So it is very important to quantify and measure the difference in warm of objects. So gaano kainit o gaano kalamig. So we are talking about temperature. Now, temperature is measured by a thermometer. Now, the SI unit for temperature is Kelvin. Okay, another units that we are using is Celsius or centigrade and Fahrenheit. So these are some of the units used for temperature. Now, so to see the difference between Kelvin and Kelvin and Celsius, the freezing point of water in Celsius is 0 degrees centigrade, while in Kelvin it is equivalent to 273.15 Kelvin. Okay, so you see the symbol of degrees in exponent form 0. Okay. Next, how about Celsius and Fahrenheit? Okay, the freezing point for Celsius is 0 And for Fahrenheit, it is 32 degrees Fahrenheit, while the boiling point is 100 degrees centigrade, and for Fahrenheit, it is 212. Okay. Now, let's go to the conversion. Okay. In converting units for temperature, okay, we need to check the quantity or the unit. If you are asked to convert centigrade to Fahrenheit, C to F, the formula is C times 9 over 5 plus 32. Or, if you do not want to use the fraction form, okay, you can use the decimal number, which is 1.8. So 9 divided by 5 is 1.8. Okay, so you can use either of the two. So whatever given centigrade, multiply it to 9 and then divided by 5, whatever is the answer, plus 32. Or, given centigrade, i-multiply kay 1.8, whatever is the product, plus 32. So in my example, so if the given is 30 degrees centigrade, you are asked to convert it to Fahrenheit. So 30 times 9 divided by 5, so that is 54 plus 32. So the final answer is 86 degrees Fahrenheit. So mamili kayo kung saan mas madali. If you want to use 9 over 5 or 1.8. Kung 1.8 naman, 30 times 1.8. Now after getting the product, plus 32, and that is your Fahrenheit. Next. Okay, how about Fahrenheit to centigrade? Okay, Fahrenheit to centigrade or F to C, whatever given Fahrenheit minus 32, after getting the difference, multiply it to 5 divided by 9. Okay, or given F minus 32 and then multiply it to 0.55. Saan galing to si 0.55? Dito yan kay 5 over 9. So, example, 86 degrees Fahrenheit, convert to centigrade or Celsius. So, given Fahrenheit is 86, so 86 minus 32 times 5 divided by 9. Okay, the answer is 30 degrees Celsius or centigrade. Or 86 minus 32, whatever is the difference, times 0.55, that is your given centigrade. And another conversion, centigrade to Kelvin, C to K, whatever given Celsius or centigrade, you just add 273.15 and then you will be getting the Kelvin result. So for example, the given centigrade or Celsius is 25. So 25 plus 273.15 is 298.15 degrees Kelvin. I hope you get it right. And if you want to be effective in converting these units, you need to practice more during your spare time. Next, let's now see the relationship or the difference between temperature and heat. So in this figure, you can see two containers, two beakers with different sizes. Okay, this one, the big beaker, and another beaker which is a small beaker, both of them are filled with hot water with the same temperature. Isang malaki, isang maliit, pareho silang puno ng hot water, pero ang temperature nila ay the same. Okay, for example, this 80 degrees centigrade or Celsius, ito 80 din. Saan lang sila nagkaiba? Dun sa size ng container or ng beaker. Now, the question is, which beaker has more heat? Sino sa kanilang dalawa ang mas mataas ang heat? Okay. So, the answer is, more mass means more heat. So, meaning, mas malaki yung container. We assume that both containers are filled with hot water. So, meaning to say, this big beaker contains more mass, meaning to say, more heat. Okay? Next. How about this? Both filled with hot water with different temperature. Pareho ng size. Okay? Pareho sila ng size. Pareho sila ng content. Saan lang sila nagkaiba sa temperature? So, ang temperature ng beaker, ng first beaker ay 70 degrees Celsius, while the other beaker is 20 degrees Celsius. So, since this beaker has higher temperature, meaning to say the molecules inside this beaker, like this, this is the representation of molecules. Okay, since it is a liquid, there are spaces in between. They can move and they can follow the shape of the container. So, having a temperature of 70 degrees Celsius, the molecules are moving fast. Okay, mabilis ang takbo nila dahil 70 degrees Celsius siya. So, meaning the higher the temperature, mas mabilis ang galaw ng mga molecules dito. While sa 20 degrees centigrade, it is moving slow kasi mas mababa ang kanyang temperature. Okay? Next. We say that the average energy due to the motion of molecules in hot water is greater than cold water. So, mas mabilis ang galaw ng mga molecules kung siya ay nasa mainit na tubig compare sa malamig na tubig. Mas mabagal. Okay. I hope you can still follow. Okay, next. So, to give you a clear picture, we say that once heat increases, temperature also increases. Pagka tinaasan mo ang init na ina-apply mo sa isang substance, dahil sa sobrang init, ang tendency ng molecules, they will tend to become excited, mas mabilis, mas vigorous ang kanilang galaw. So, pag mas mabilis, ang kinetic energy nila ay mas mabilis, okay, ang motion nila ay mas mabilis. So, meaning to say, ang kanilang temperature ay tataas. So, it is directly proportional. When heat increases, temperature also increases. Babaan mo yung heat, bababa din yung temperature. Okay? So, how about this? Again, we have two containers. But the first container, it contains only 250 cc, okay, of water, while the other container contains 500 cc. So, ang tanong, sino sa kanilang dalawa ang mabilis makaka-attain ng 100 degrees centigrade or Celsius o yung boiling point? Sino sa kanila ang mabilis kukulo? Yung beaker na may 250 cc o yung beaker na may 500 cc? So definitely, obviously, tong Q1, tong 250 cc requires less heat to attain 100 degrees centigrade. Vice versa, ito, greater heat ang kinakailangan niya bago niya ma-reach ang 100 degrees centigrade. So, nandun na papasok yung mass factor. Okay, next. Now, paano ba nagta-transfer ang heat energy from one body to another body? So, sabi natin, yung heat transfer, okay, we need two bodies of different temperature comes closer. So, when two bodies of different temperature comes closer, so what happened? From the higher temperature object, from an object with higher temperature to lower temperature or lower temperature to higher temperature. So, let's see. So, for example, these are two metals, one having higher temperature and another lower temperature. So my question is, what is the direction of the heat flow? Okay, so in this diagram, it is very obvious that the flow of the energy will come from the higher temperature going to lower temperature. Laging sa mas mataas muna, pababa. Okay? So, yun yung flow ng energy. Kumbaga, yun yung trend. From higher temperature to lower temperature. So, it will come to a point na once na transfer niya na yung energy, darating yung punto na magiging pareho ang temperature nila. If they have same temperature, it is now called, or they now attain thermal equilibrium. Parehas na ang kanilang temperature. Okay. Ulitin natin na ang trend, ang flow is from higher temperature going to lower temperature. So, pagka na-transfer niya na at nagpantay na yung kanilang temperature, they now have the thermal equilibrium. Okay, so let's go now to the methods of heat transfer. Paano ba na ita-transfer ang heat energy? So there are three methods. One, conduction, another, convection, and the third one is radiation. So what is the difference between three methods? So let's start with conduction. When we say conduction, the transfer of heat requires medium. Dapat may materials na in contact. For example, okay, itong lighted candle, tapos yung metal rod, idinikit mo. So from this, okay, the flow of energy is going to the hand, okay, because the molecules continuously travels going to your hand. So from body to body to body. So yun yung conduction. Ganon din dito pag nagluluto ka. So this is the fire from the stove, or the flame from the stove, which is the source of heat. And your pan is definitely, it is a kind of metal. So once na yung heat energy transfer to this pan, and then you hold the handle using your bare hand, natural, mapapasok ka. Kasi nag-travel yung heat from one object to another object. So that is conduction. The same with this example. If this is a hot milk or hot coffee, whatever hot substance it contains, so definitely hot siya. Pag naglagay ka ng metal spoon, pag hinawakan mo yung metal spoon, mapapasok ka. Kasi nga, yung heat coming from this substance transfer or travel to the handle of your metal spoon. So, yun yung conduction. It requires a medium. Kumbaga sa bola na dikit-dikit, from ball 1, ball 2, ball 3, ball hanggang doon sa dulo, sunod-sunod yan. Okay, next. Sa conduction, meron tayong tinatawag na materials. Okay? May dalawang klase. Pag conductors, Okay, lahat ng metal ay example ng conductors. These are the materials that we call conductors. Siya yung mga material na these are the materials that allows the heat to pass through. So, pwede siyang daanan ng heat. So, ang tawag dyan ay conductors. Okay? Ang vice versa ng conductors ay yung tinatawag nating insulators. Okay, if conductors allows heat to pass through, ang conductors hindi. Hindi niya pinapayagan dumaan ng init. So, kaya nga pagka yung ating mga frying pan, okay, yung mga kitchen utensils natin, design sila na itong parte na to should be conductor para daanan ng init. At ito, para hindi ka mapaso, it is usually wrapped with insulators. So examples of insulator, it could be wood, rubber, and plastic. Okay? Now, let's go to the next method of heat transfer. We know the other method is what we call the convection. Sa convection, there is no contact. Okay? But how does the heat transfer through convection? So example, yung casserole na to filled with water, pag nilagay mo sa ibabaw ng open stove, the heat coming from the stove going to the kitchenware, which is made up of metal, may initan yan. So, ito pa lang, dito pa lang, conduction pa yan kasi may medium. So, what happened inside the molecules, the molecules of this water? So, nagkakaroon dito ng convection. So, yung molecules na pag nainitan siya, so the tendency of the molecules, pag naiinitan, they will scatter. So, pag nag-scatter sila, nagiwahiwalay, ibig sabihin, less dense, gagaan sila. So, once nagumaan sila, naging less dense, saan ang direksyon? Pataas. Okay? Pag tumaas na siya, dahil nga naging less dense, gumaan, tataas. Pagdating sa taas, at malalamigan na naman siya, ang tendency, magiging closer sila ulit, tong molecules. So, pagka naging closer, naging high dense na yung molecules, the tendency for them is to sink. So, yung cycle continues lang yan. So, yun yung tinatawag nating convection. Okay, you heard about the convection current. So, ganito rin yan. And this is true for fluids. Pag sinabi natin fluids, substance that flow. So, what are the substances that is considered to be fluids? These are gases and liquids. Okay? So, pag tinapat mo yung kamay mo sa kumukulong tubig, okay, you don't need to soak your hand para malaman mo siyang mainit kasi kahit nandun siya sa ibabaw, walang direct contact ka dun sa surface, may initan ka nga because of the convection. Okay? Okay, next. How about radiation? Ang radiation naman is the transfer of heat. This transfer of heat requires no medium. So, in my example, this boy, kahit sobrang layo ng distansya niya kay Haring Araw, once the sun emitted sun rays, so tatamaan tong batang to ng radiation kahit walang medium na dadaanan. Ang tawag doon ay radiation. Okay? Kaya nga 'di ba, pagka ang mga bata o kahit tayo matatanda, hindi tayo nire-require na na-expose ng husto sa ilalim ng init ng araw kasi it can cause cancer of the skin or too much radiation coming from the sun na kahit sabi mong wala pang daanan yan, it could travel so fast by means of radiation. Okay? So, let's see the difference between heat and temperature. Okay. To have a recap, we say that heat is the total amount of energy in a substance. Total amount, kabuuan. So, yan yung heat na tinatawag natin. So, heat can travel, transfer, and it can flow. Okay, ang unit na ginagamit natin sa heat, usually calorie and joules, or capital J. While temperature is the average energy due to the motion of molecules of a substance. It is the average energy due to the motion of molecules of a substance. Okay, as the heat increases, temperature also increases. So they are directly proportional. Pag tumaas ang heat, tataas din ang temperature. Okay, bakit nagkaganon? Pag nainitan ang isang substance, the tendency of the molecules is to move faster. They will move vigorously. Okay, napakabilis niyan. So, pag bumilis ang galaw, so ibig sabihin, tataas din ang kanyang temperature. Okay, vice versa, as the heat decreases, temperature also decreases. Next, heat flows from a body of higher temperature to the lower temperature until both attain the same temperature. So sabi natin, the direction of the flow of energy, of heat energy, will always comes from the higher temperature going to lower temperature. So, kung meron kang hawak na ice cube sa kamay, okay, bakit natunaw yung yelo? Saan nanggaling ang heat? Nanggaling yun dun sa kamay mo. Okay? Kaya natunaw yun. So, pag merong kinuha kang isang pitcher ng malamig na tubig na meron pang ice at ilabas mo sa ref, after a few minutes or hours, makikita mo bakit siya uminit. So, ano nangyari? Ganon din ang explanation nun. Okay? The greater the amount of the substance, the greater the heat required to raise its temperature. So, mas marami daw yung substance, mas marami yung heat required para pataasin ang kanyang temperature. Okay. For our next activities, in our asynchronous lesson, for our supplementary activities, you can do your what's more and what I have learned. Okay, thank you and have a great day. Keep safe, maintain cleanliness, and wear masks. Have a great day.